When's our next notebook check? Anybody remember what I've been telling y'all? After Thanksgiving. After Thanksgiving, I'm checking your notebook for units 3, 4, and 5, and that's a quiz grade. So make sure if your notebook is not right with the Lord, you get it right with the Lord over Thanksgiving break. Capiche? I'm giving you break to get it caught up, some of you, so that you don't get a bad quiz grade. Huh? Yeah, you did for answering my question. You sure did. What, babe? You said a lot of people got extra credit? Yeah, anytime you answer a question, like you just answer questions in vocab, you got extra credit points. I keep track of it and I'll put them on your test. All right, systems of equations review is what we're doing today. Make sure that's in your notebook. I can help you. You just got to ask me for help. I can help you later. So you might want to skip some space. Go to the next page. Go, yep, right there is fine. Page 41, systems of equations review. Write that down. I can get you caught up. You good, Khalil? All right. My kiddos at home, y'all good for me to flip?
Yeah, you can go ahead.
All right. Hey, Brooke, I miss you. Where you at?
I miss you too. I'm home.
You left me here with all these boys.
I overslept. That's the reason why.
Are you going to be here tomorrow?
Yeah, I'm going to be here tomorrow, though.
Okay, good. I'm going to play a Christmas movie for y'all while you're working on your classwork.
Oh, my goodness.
We can vote afterwards, after class. What'd you say? A Christmas movie? As long as y'all are good today. So I did tell them y'all have an assignment tomorrow, but it's just on what we're doing again today. It's a practice assignment, and you'll have the whole class period to do it. So you shouldn't have homework over break.
Wait, this is a review?
No, baby. We did the test. You took the test Friday, boo.
No, because this says systems of equations review.
Yeah, because this is something you should have learned in 8th grade.
Oh, okay.
If you didn't, it's okay. I'm reteaching it, but it is a review for a lot of kids. Okay. All right. So the first thing we're going to do, we're going to start off with an example because I feel like you guys do better when we do that, so you can look at it and try to think it through. So I'm going to start off with an example. X plus y equals 7, x minus y equals 1. Everybody write it down. Write it down. You're going to want this in your notes, I promise. And this is what we're going to think about. We're going to think about what it means to be a system of equations. So what I wrote down is, what does it mean to be a system of equations? Forgot you a fast writer. Good. All right, so I am going to put the vocab back up just for a second. Y'all keep writing if you're writing. I do want us to look back at our definition for system. It's a group of 2 or more equations written using the same variables, right? So everybody look at the example I gave you. Is this 2 or more equations? It's 2, right? Okay, do they have the same variables? So is this a system? Yes, this is a system. I've got 2 equations with the same variables. Remember, your variables are just your letters. They both have an X and a Y. So this is a system. It's 2 equations with the same variables. So now I want us to look back at our vocab at the word solution down here. The solution to a system is the ordered pair that makes both equations true. So listen to me carefully. We're looking for the ordered pair, the X and the Y, that would make both of these equations a true statement. So listen to me. Let me put it in perspective for you. Jalen, you paying attention, baby? What two numbers can I add to get 7, but then when I subtract them, I'll get 1? What two numbers add to give you 7, but if you subtract them, they'll give you 1? That's all you're doing. You're looking for what two numbers add to 7, but if I subtract them, I get 1. So my boys are kind of looking at me. So let me give you an example. Would 5 and 2 work? 5 plus 2 is 7, but does 5 minus 2 equal 1? Hang on, you got it? Hang on. My online people, did y'all hear me? 5 plus 2 is 7, but does 5 minus 2 equal 1?
No.
No. So my boys in class are going, oh, okay, it's 4 and 3, right? Good job, Jalen. 4 plus 3 is 7. And when you do 4 minus 3, don't you get 1? So the solution for this system would just be the ordered pair 4, 3. The x would be 4 and the y would be 3. That would make both of these equations a true statement. That's all we're doing today. Exactly. Can you tell me why? Let me tell them what you asked because that's good. He said, what if you flip the 3 and the 4? Would it then be wrong? And I said, yes. And he's about to tell me why. Why would it be wrong? Because 3 minus 4 is -1. So then that pair won't work. It's got to be 4 as the x and 3 as the y. Very good, Cam. Look at y'all getting extra credit. So proud of my boys. All right. Does that make sense to people at home what we're doing today? We're just talking about two equations that have the same variables. Now, it does get a little bit trickier because they can put numbers in front of the x's and y's. So you're not always going to be able to do them in your head like we could this one. Most of the time we need some work, okay? All right, so let's start out with vocab, the 4 words that I didn't go over.
We gotta do vocab cards for these.
What, baby?
We have to do vocab cards for these.
For this unit, yeah, you joined late. Can somebody tell her when vocab cards are going to be due for this unit? Monday. Good. This coming up Monday, Brooke. So you got a week, but also that's going to be the only assignment for virtual Monday.
All right.
Okay. All right. You can have 3 different types of systems. So this is where your vocab comes in. Hey, Jordan. Other Jordan.
Hey.
I got both my Jordans in here. All right, you can have 3 different types of systems. The first type is called consistent independent. So let's dissect this. Y'all let me know if I'm going too fast. But let's dissect this. What's the word consistent mean? You don't have to tell me in math, just in general. What does it mean to be consistent?
Repetitive.
Okay, repetitive. You keep doing that same thing, right? Consistent basically means the same. So if a system is consistent, that means it has one solution. It's going to be the same x and the same y. Does that make sense? So I want you to put down consistent means same. We're just going to put same. Trying to break it down for y'all so that it makes sense. So if a system is consistent, that means they're gonna touch somewhere, because if they're the same, that means they're gonna touch, right? All right. What does the word independent mean, y'all? Oh, good, by itself. Do y'all know how to spell independent? I'm getting off topic. Uh-huh. Y'all ever heard that song, Independent?
I know exactly what you're talking about.
I-E-N-T. Do you know what that means? She got her own house. She got her own car. You never heard, Lord, Brooke, I'm gonna have to play that for them. That's by Nelly, I think. Like super old. That's okay.
They don't know about that, Miss Paul.
They don't know about it. Brooke knows about it because she got older siblings and stuff. That's okay. Independent means by itself, one thing, right? So by itself, one thing. So put the two together. If a system is consistent and independent, that means it's going to touch how many times? One time. So a consistent, independent system has one intersection point, which means it's got one solution, right? Because we talked about in the vocab, the intersection point is the solution. So that's the first type of system you can have. The two lines cross and they touch only once. That is called consistent independent. So let's draw a picture for it. Y'all know I'm a picture person. A consistent independent system will look just like this, and they will touch one time the two different lines at the intersection. What did you say, Jordan?
Slide up so I can see the type.
I'm not gonna move it where my people can't see what I just wrote though, because you got on late. There it is, real quick. Got it?
Yeah, I got everything else. Just
okay. Okay. Is everybody good with consistent independent? The two lines touch in one spot.
Mm-hmm.
Good. All right. After vocab, y'all, it's just examples, so y'all hang with me. Let's see if we can dissect this one and figure out what this one means. Consistent dependent. What's it mean to be dependent? Okay, so if you depend on somebody, are you doing it by yourself? Nope.
No.
So if you're consistent dependent, you got some help from somebody, right?
Mm-hmm.
So I want y'all to look, consistent dependent systems. Remember, we're still talking about two lines, two equations. If a system is dependent, but it's consistent, that means they touch, but they're going to touch the whole time because they depend on each other. Does that make sense? It's not just going to be once. It's going to be them touching the entire time. So let me show you what consistent dependent lines look like. Here's the first one. And then the second one is literally going to be right on top of it. So what kind of lines do y'all think are going to be consistent dependent? What did I just draw? Well, yes, they're dependent, but the green and the blue line, are they different? Are they the same? The same exact line. Good, Jalen. Same exact line. So consistent dependent means it's the same exact line. They touch everywhere, which means how many solutions are we going to have? Multiple. How do we write that in math when it's more than one, when it's a lot of different answers? Because it says they touch everywhere.
Infinite.
Good. Infinitely many. This one, right? Infinitely many solutions. Y'all remember learning that in middle school?
Mm-hmm.
All right. I think in middle school you like learned about these different types. They just didn't tell you the names. So that's a consistent dependent system. If they're the same exact line, that means they'll touch everywhere. And so they're going to have many solutions. All right, am I good to do the last one? Okay. So then the last kind you can have that's on your vocab sheet is an inconsistent system. All right, y'all, so look at your notes. What did we say consistent meant earlier?
The same.
The same, which means they will
Touch.
touch. So everybody look, Cam, you looking? If consistent means they're gonna touch, what would inconsistent mean?
They don't touch.
They don't. Inconsistent means there's no intersection, which means, do we have a solution?
No.
No. Remember what you wrote on your vocab sheet. A solution is the intersection point. So if they don't touch, that means there is no solution. So I'm going to go back to middle school again. In middle school, y'all learned about a type of line that should never touch. What kind of lines never touch?
Parallel lines.
That's not a great picture, but y'all know art is not my thing. Parallel lines never touch. So an inconsistent system is if they give you parallel lines. They're not going to touch. It'll be no solution. If I give you two equations that end up being the exact same, that means the lines are the exact same. So they're dependent. They'll touch everywhere. And then if I give you two completely different lines, they should cross at one point. Those are called independent. Do we feel okay with this vocab? That should help a lot of you with your cards. Not hard. Consistent independent card, 1 point. Consistent dependent card, many solutions, or you could put same line. Inconsistent card, you could put no solution, no intersection, parallel lines, okay? All right, so let's talk about why this is important. And then we got examples and we'll be done. So how can we solve a system of equations when it's hard to do it mentally? So what I mean by mentally is that first example I gave y'all where we just did x plus y is 7 and x minus y is 1. That was pretty easy to figure out in our heads. But what if it's taken us a really long time to do in our heads? What if it's kind of challenging? How else do y'all think we could solve a system of equations? We were doing it on the front, underneath those 3 vocab words. The pictures I was giving y'all, what were those? You don't know. What we draw underneath each of those 3 vocab words? Not the light bulb words. I'm gonna flip so y'all can see. Lord Jesus. What did I draw? What's this blue things? What's the blue and green? What's the red? Lines. If you can't do it in your head, how can you solve a system? You can graph the lines and see where they touch. Thank you, Cam. We can graph the lines. All right, kiddos, don't y'all dare act like y'all don't know how to graph some lines, because who taught you how to graph lines? In 2 whole units, me. So we about to find out who was really paying attention. I told y'all back in units 1 and 2 that you better know how to graph these lines because they're going to come back. Here they are. So how can you solve a system of equations? You can graph the lines and see where they touch. Does that make sense?
Mm-hmm.
All right, so this is where the vocab comes into play. If you can look at the 2 equations and you can tell the 2 equations are the exact same, do you need to graph it?
No.
Really?
Yeah. No.
I want it. Why not? If the 2 equations are the exact same, what's going to happen? The lines are going to be touching everywhere, which means how many answers will we have?
Oh, you'll have many solutions.
Many. So you don't need to graph that. If the equations are the same, many solutions, they're going to touch everywhere. What if I give you 2 equations that end up being parallel? Do you need to graph it?
Yes.
No. Oh,
No.
what do we know about parallel lines? Do they ever touch?
No.
No. So you don't need to
Oh.
graph those either. It'll be no solution.
Solution.
Good, Brooke. So the only ones we have to graph, guys, are these, where they should cross at one point. So who remembers from unit 2 when I taught you about parallel lines? How do we tell if 2 lines are parallel?
Oh,
The equations, not the graph.
Oh man, I remember, but I forgot.
Where's my Ashley at? Come on, my girl.
I remember for real. I just can't think of it right
Uh-oh. No, that's perpendicular. We're not dealing with perpendicular, just parallel. Parallel lines are the easy ones. What do we know about parallel lines? They don't touch, but it's because something's the same. They got the same. What numbers? What am I doing with my fingers? I'm rising and running, which is the
Slow.
oh my God, who said that? Was that Brooke?
Yes, it was Brooke.
The rest of y'all hurting my feelings today. Dang, parallel lines have the same slope. I taught you that back in unit 2.
Yeah, I was gonna say that, but I didn't want to be wrong though.
Well, who cares if you're wrong? The rest of them don't seem like they know what they're doing because they ain't answering. So it's okay. Parallel lines have the same slope. If I give you 2 equations where the slopes are the same, do you need to go graph them?
Nope.
Nope, because they're going to touch nowhere. They're parallel, okay? So we need to graph when they're not the same and when they're not parallel. Do I need to write that down, or y'all are good just listening to that? Okay, they said they're good listening. Anybody online need me to write that?
Yes, you write that.
I can write it for you.
Thanks.
We'll put a star. If the equations are the same, what did we say if the equations are the exact same? What's the answer going to be? Good, Cam. Infinitely many solutions. You can just put many. We talked about that in unit 1. I don't care if you put the infinity sign. And then if the equations have the same slope, Jordan, I'm sad you couldn't tell me that, boo. I know you know that. If the equations have the same slope, that means they're parallel, which means what will the answer be if it's parallel lines? Khalil, you better be paying attention. I'm about to throw something at you.
If it's parallel line, it's gonna have no solution.
Good, Brooke. That means it's no solution. So you don't have to graph these 2 if you can look at the equations and tell. But if the equations aren't the same and neither are the slopes, you're going to have to graph them to see where they cross. Okay? All right. I feel like we just need some examples and then we'll be good to go. So for all these examples, we're gonna have the same directions. So I'm gonna write the directions above it. So the first thing you're gonna do for each of these is tell how many solutions there are. And then you're gonna solve by graphing. So there's 2 parts to each example. I have 4 examples planned. If y'all need more, we can do more. If you feel good after 3, we can just do 3. I'll leave that up to y'all. I'm gonna have to quiz y'all tomorrow on these infinitely many and no solution and 1 solution. Some of y'all were struggle busting a little bit. All right, example 1, write down these 2 equations. Got them down, Khalil? Remember, we're doing notes today, but there's no notes tomorrow. It'll be on the same stuff. So if it seems like a lot, just know we're not doing any tomorrow. All right. Can we tell if these lines are the same? Nope.
Mm-mm.
You can't tell always. You can't tell if they're parallel yet either. Can somebody tell me why? This is review from Unit 1.
Because
We're not solved for what? What form do lines have to be in? Well, I got X's and Y's. What's my equation of a line? What does it look like? What's the formula? Y equals, oh, wow. Woo. Some of y'all got some reviewing to do before you take this exam, because this ain't looking so hot for some of you. Y equals M.
X plus B.
There's Ashley. Lines should look like Y equals MX plus B. Until you make them both look like that, can you tell if they're the same? No. Can you tell if they're parallel? No. Can you tell if they're completely different? No. You got to get them in Y equals first. Did everybody hear me say that?
Mm-hmm.
All right. So before I can even tell how many solutions there are, I got to get them both in Y equals. So let's review how to do this. If I want Y by itself, what do I do to Y?
Take it away.
What am I doing to Y? Look at my finger. What am I doing?
Covering it.
Thank you, Ashley. Whoo! Cover it. This is review back to Unit 1. You want Y by itself? You cover it up. What do I need to move? Not yet. That's with the Y. It's covered. The X. How do you guys move a positive X? Because it doesn't have a negative sign. Subtract it. Good, Ashley. The opposite of a positive is a negative. Subtract your X over. What, babe? I think you did pretty good in first 6 weeks. This is from first 6 weeks. 2Y equals. Which one do I write first if it's supposed to be MX in the front? Which one do I write first? Let me ask y'all this question. Can you do 4 minus X? Good. You can't do 4 minus X. So what'd y'all just say? Y'all told me which one.
4.
Oh, which one do we write first?
The MX.
The
MX.
MX. Good. Which would be negative 1X, right? That's got an understood one with it. Plus 4, because that's a positive 4. Very good, Shania. All right, kiddos. Now what do I do to get Y by itself?
Divide everything.
Good. She's with me. There we go. There's my girls. Divide everything by 2. And so I'm going to get y equals what? What do we get?
1/2 plus 2.
Negative 1/2 x plus 2. That's your first equation. Now I'm going to do the same thing, but with the other one. Thank you, Cam. You got to put them both in y equals so you can see how many solutions it's going to have. So for the second one, 3y minus 2x equals 6. What do I want by itself? What are we solving for? Be careful. Y equals, we're solving for y. So what do I go cover, kiddos? Cover the y. What do I need to move? The negative 2x. How do you move a minus 2x? Good, you add it. Add 2x, move it over to the other side. All right, so now what do I write? What do I write? 3y equals 2x. Look at you, I'm so proud of you. You're doing so good. He's killing the game. And then how do we get y by itself? Divide by 3, very good. All right, y'all. So are y'all getting y equals 2/3 x plus 2? People at home, do you guys remember doing this in Unit 2, solving for y, getting it by itself so we can see the two lines? Okay.
Yeah.
Okay, good. If you don't remember doing that, you probably need to come to office hours because this is what we're doing today and tomorrow and next week. All right, look at these two lines. Are they the same? Nope, not the same. Are they parallel? No. Cam says no. Y'all agree no? Jalen, you paying attention? They're not the same. They're not parallel. Look at your slopes. This one is negative 1/2 and this one is 2/3. So they're not the same. They're not parallel. That means they should cross at one point. So how many solutions? What's the answer to A going to be? One solution. Who remembers what that's called? Because on my test, I ask you what that's called. Consistent, what if it's one?
Independent.
Good, Ash. Consistent, independent. I'm going to abbreviate. There's part A. So on Delta Math for homework tonight, you'll get both the equations and y equals, and then you'll tell me how many solutions. Is it one? Is it many? Is it none? Those are your three options. Now, part B says solve the system by graphing. So I'm going to draw a graph and graph these two lines on it and see where they cross. That will be my solution. Is everybody okay with that? All right, so let's graph it. Let's review y'all's graphing. If you don't have graph paper in your notebook, my people in class, I gave y'all graph paper. Go, Leo, don't touch it again. So I'm marking and nail you right in the head. Draw a graph. If you don't have a graph in your notebook, I gave you graph paper. And I'm going to use different colors so y'all can tell what I'm graphing. All right, I'm going to do the first equation in purple. What's the base of my first equation? I'm so sad.
2.
Ah, there she goes. 2 on the what, Ashley?
Y.
Good job. It says y equals 2. So everybody watch, just a review of how to graph. Go up to 2 on the y-axis, put you a point. I hope we're paying attention. You with me? Okay. Up to 2 on the y-axis, put a point. What's the slope, Ashley?
Negative 1/2.
Good. So people at home, if it's negative 1/2, what does that mean? How many do I go up and down, and how many do I go over? Up. Down 1 over 2. Jalen, pay attention, boo. Down 1 over 2. Down 1 over 2. That's your rise over run, right? Down 1 over 2. Down 1 over 2. Here's your first line. Boom. Now I just got to go graph the second one. Let's do our second one. I'm going to do that one in red. What's the base of the second equation?
2.
Good. It's on 2 again. So I'm going to put that point in the same spot. And then what's my slope of the second equation?
2/3.
2/3. So look, guys, it's positive. If it's positive 2/3, that means I go up to, good, over 3. Up to, make my hand so y'all can see. Up to, over 3. And connect. So what's the ordered pair where they cross? That's not an ordered pair. That boy said 2. Y'all better get your classmate. Ordered pair. What's this ordered pair?
0, 2.
Good. So your solution to this system is 0, 2. How many more do y'all think we need to do? 1, 2, 3. Just one more and we'll be okay? All right. The boys in class are saying one more. People at home, what y'all think? How about I do one more in your notes on paper, and then I can do one off your homework in Delta Math with you. How's that sound?
Yeah.
All right, let's do that. There we go. All right, example 2. Same direction, so I'm not rewriting the directions. We're going to tell how many solutions, and then we're going to solve it by graphing. Let's do this one. 9x minus 6y equals 24, and 6x minus 4y equals 16. All right, what do you have to do first to even be able to look at the lines and figure out how many solutions? I think you were. Are you working ahead or are you just writing it down? Okay, I'm used to you answering my questions. Hello? Y'all don't make me
Solve for y.
Oh, who said that? Shania?
Yes.
Yes, girl. Solve for y. Look at me. You cannot tell how many solutions until you have both lines and y equals. Jalen, I hope you're paying attention, babe. Okay, you worrying me just a little bit. 6y equals 24. I'm going to solve them both for y. So, Shania, if I'm solving for y, what do I need to do to y?
Cover it up.
Cover it up. Good job, girly. So, y'all, what do we need to move?
9x.
So, how do I move a positive 9x? Because there's no negative.
Subtract 9x.
Subtract it. Good job, girly. Subtract the 9x over to the other side. So now what am I left with? What kind of 6y? There we go. Don't forget that negative 6y equals what?
Negative
Negative 9x plus 24.
Good job, y'all. And Ashley, what do I do now, babe?
divide the negative 6.
Good. Divide by negative 6. Divide by negative 6. So I'm going to get for this first one, y equals. What happens when you have negative divided by negative? It's positive. Good. And guys, what does 9 over 6 reduce to?
3/2.
Very good. 3/2. She divided them both by 3, if you're wondering how she got that. 9 divided by 3 is 3. 6 divided by 3 is 2. She took out the GCF. 3/2 x minus, because a positive divided by a negative should give me a negative. What's 24 divided by 6?
4.
4.
Good job, y'all. So there's your first line, 3/2 x minus 4. Now I got to do the same thing, but with the second one. All right, Cam says, Are you already done over there? I'm so proud of you. All right, I want to solve for y, so what do I do to y?
Cover it up.
Covered up. Good. How do you move a positive 6x?
Subtract 6x.
Okay, subtract 6x. Subtract 6x. So do y'all agree that we're left with negative 4y equals negative 6x plus 16?
Mm-hmm.
Will, you okay, babe? Then how do you get y by itself?
Divide by -4.
Yes, look at her go. All right, so let's reduce. Y equals negative 6 over negative 4 reduces to what?
3/2.
3/2x. Okay, Jalen, I see you. What's 16 divided by negative 4?
-4.
Uh-oh. Okay. Why am I saying uh-oh?
Because they're the same.
They're the exact same. So look at me right now. Everybody look at me. Do I need to graph it? No. What do we know if the lines end up being the exact same? How many answers am I going to have? Many. Very good. Many solutions. And you don't need to graph it because how many solutions are there going to be? Infinite. So we don't need to graph this one. So do you see why it was so important in Unit 2 that we learned how to get y by itself? That was Unit 1, actually. Everybody see why I taught you to solve for y equals? Because if you can solve them both and you can see they're the same, you don't need to go graph it. It's going to be many solutions. You just saved yourself some work, okay? Do not go anywhere. If you joined the live class Zoom, I'm rewarding